Well, hello everybody. Thank you for joining. My name is Josh Hannon, and I'm one of the members of the Flow team at Dapper Labs, and I'm also a member of the NBA Topshot team. On the Flow team, I lead the development of many of the Flow core smart contracts, and I'm assisting with the design of our smart contract programming language, Cadence. And then on the NBA team, I also lead the design of the NBA smart contracts, and help with integration and testing there. So I'm going to share my screen, and can I get a confirmation that everyone can see it?
Yes, perfectly.
Perfect. And today I'm going to give a talk about the NBA Topshot smart contracts, but primarily using the contracts as an educational tool for learning the basics of Cadence. So in case you don't know very much about NBA Topshot, Topshot is a game that Dapper Labs has been working on for a long time. That is the official NBA game for collectors to collect these NFTs, non-fungible tokens, that show off highlights from NBA basketball games. We've been working very closely with the NBA and the NBA Players Association to create a really fun and exciting experience for players, or for game players to really collect pieces of important and exciting NBA games that are represented as collectibles on the Flow blockchain. And just to give a quick rundown of what these collectibles are, collectibles represent highlights from specific NBA games, and the collectibles will contain video of whatever highlight that's being shown, and also will contain various imagery from the player who the play is associated with, and then various stats from Sports Radar that is also associated with the play that's being used for the highlights. So, and then of course, since this is on the Flow blockchain, all of these will be represented as non-fungible tokens, and we'll have on-chain ownership, provable ownership, and users can do whatever they want with these NFTs outside of the Topshot game. But we also will be building in different experiences into the Topshot game that use these moments or these collectibles. Somebody is, I'm getting feedback from someone. Okay, there we go. So now I'm going to go into talking about Cadence a little bit. So back in 2017 and 2018, when Dapper Labs was doing CryptoKitties and seeing what blockchains could do, we had a realization that this blockchain and smart contract programming paradigm was new, and we needed to think about programming for these applications in different ways than how we thought before. And with these new programming paradigms, they're always going to bring new languages into the world. And we had been working with Ethereum and Solidity, and we're mostly okay with that, but we wanted something a little bit more well suited for dealing with these assets that actually represented objects of real value. And so we decided when building Flow, our blockchain, that we wanted to build our own programming language that really solved a lot of these problems of like security and safety and ease of use that we had struggled with when working with other smart contract programming languages. So the main two the most important parts of dealing with like programming in the blockchain domain is they both center around managing these scarce assets, your currencies and your collectibles and securities and all these different kind of value holding objects that are being represented on a blockchain. So programmers and users need a way to securely manage these scarce assets and additionally control access to your assets. Given the public nature of blockchains, it's important for users to be able to have strong guarantees about who they can allow to access certain functionality of the assets they own. Currently, in Solidity, these assets are represented as just traditional data structures, and managing access is managed through access control lists, which are just a list of addresses, account addresses that are allowed to have access to a certain functionality in an application or in a program. And unfortunately, those concepts don't fully map onto the scarce assets that we want to be able to manage in a blockchain programming environment. Data structures are easy to create, easy to copy, easy to delete and destroy. But when you think about how we actually want to manage these assets, those properties actually are a detriment to how we deal with these objects. With currency, for example, we want to be able to carefully control the creation of these assets. We can't just let anybody create them. And then similarly with copying them, with a regular data structure, it's easy to just make a copy of something and make as many copies as you want. And as I'm sure you understand, we wouldn't want to allow people to just be able to make copies of currencies and collectibles. Additionally, one of the most important things is not allowing these assets to be lost or destroyed unless the owner specifically has chosen to destroy it. So we needed a way to represent these assets that makes it really hard to lose them or destroy them. So as I was saying, in Solidity and WebAssembly, which are the two other smart contract programming languages, these scarce assets, scarce resources they're just data structures. So we decided that in Cadence, our smart contract programming language, and in the Move programming language, which is associated with Libra, these assets are resource objects, and resource objects are similar to traditional data structures, but they have special rules about how they can be interacted with and managed in a programming environment. And bringing it back to Topshot NFTs, the Topshot collectibles are represented as these resource objects. So the main properties of resource objects are that they cannot be accidentally deleted or lost. With the normal data structure, if you get if you get to the end of a execution of a program and that data structure was used in that program and isn't handled or stored somewhere, it's just garbage collected and goes away. But with a resource, the program would not compile because it would require you to store this asset somewhere safe or delete it explicitly before allowing you to actually execute this program. Resources are also not allowed to be duplicated. With structures, you can just copy them, but resources explicitly disallow copying. And then similar to this, there's no way to forge a copy of a resource. So like for the Topshot NFTs, somebody couldn't just deploy another version of Topshot and pretend that their Topshot NFTs are the same ones, because they're specifically tied to the program, that the original smart contract that defined it. And additionally, instead of representing ownership of these objects in a ledger like most other blockchains, these Topshot moments and all resource objects actually live in the storage of the account that owns them. So in each NFT, each resource is private to the owner of it, and the owner has full control over who can access that object, what they want to do with it. And so if somebody doesn't want others to be able to access their object, they don't have to allow it. They get to manage that. So before I get into how the Topshot smart contract manages these resource objects, I just want to give a very brief overview of some of the constructs in Flow and in Cadence. So in Flow, like many other blockchains, Flow has a account and transaction programming model. Accounts are where code is stored, and the code is represented in contracts, and these contracts define special types and functions for interacting with those types, and then transactions are temporary blocks of code that are used to interact with contracts in various accounts. And so, as you can see in this example, this simple contract, example contract, defines a resource called token and a function to create one of these tokens. And just so we can be clear, the contract doesn't actually explicitly store an instance of this token object. It just defines the behavior of it and the functions that can be used to interact with it. And if a user wanted to actually get a real token object that they could have for themselves, they would create a transaction that calls this create token function that creates this token, which then they could put into the storage section of their account. And in these diagrams, I'm representing actual objects as with this blue outline. So every time you see a blue outline, you know that is an actual resource object that is stored in a user's account. And then I've also represented transactions with this dotted outline, because the transaction is ephemeral, and once a transaction has been executed, the transaction goes away, and the state of the state of the code and the storage persists. And currently, externally submitted transactions are the only way to interact with on-chain code. So this is how all the interactions are modeled and executed. in the Flow blockchain. So I'm going to give you a very basic example of how the Topshot contract works. So at its core, the Topshot contract defines a resource type called NFT, which is the representation of the Topshot collectible, otherwise known as a moment. And the contract defines this NFT object, and also defines another resource object called a collection. And a collection is a construct that allows users to store their moments and have special functions to be able to interact with those moments. For example, a collection would allow a user to read certain metadata about the moments that are stored in their collection. It could allow a user to withdraw moments from their collection and deposit them into their collection, or get a list of the moments that are in their collection. So it's just provides utility functions, so the user can easily interact with the NFTs in their storage. And then additionally, there is a function in the Topshot smart contract that allows a user to create an empty collection. So in Cadence, differently from Solidity, if you want to be able to interact or store an NFT in your account, you need to actually have set up your account to be able to store these NFTs. So this helps protect against mistyped account addresses, causing NFTs or tokens to be sent to the wrong address. Because if that address isn't set up to receive those, then that transfer will just revert. So that covers the core of the Topshot smart contract. And all these other boxes surrounding this code represent various accounts in the network that all have a Topshot collection in their storage and have different Topshot NFTs stored in that collection. A collection can hold any number of NFTs inside of it, and if a user wanted to transfer one of their NFTs to a different user, they would simply create a transaction that withdraws their NFT from their collection, which moves it out of the collection into the context of the transaction. Then that transaction would move that NFT into the storage or into the collection of the user that they wanted to send it to. And so transferring is as simple than that. Obviously, transferring is probably the most basic thing that Topshot users are going to be doing with their NFTs. But the power of Cadence is that these contracts, they just define the kind of the bare minimum functionality for interacting with these objects, with these collectibles, and then we can write other smart contracts that import the definitions for these objects that can then do whatever we want with them. And I'll cover that a little bit later. But first, I'm sure you're wondering about kind of wondering about the different details that the Topshot contract has separate from these core definitions. And this is where we get into how moments are classified. So in different collectible card games and baseball cards and things like that, we have the concept of grouping these collectibles into different sets and series. So in the Topshot smart contract, we wanted a way to group these plays and moments into sets so that we could efficiently store all the metadata associated with each moment in the central contract, so that users could easily access the metadata for their collectibles, as well as other apps and smart contracts accessing this data. So the first concept in Topshot is a play. So this is just a single highlight from a game that Topshot that we've taken from a basketball game and turned into this data structure in this Topshot smart contract. It contains all the play related metadata, like the name of the player, the name of the team, the date of the game, and that metadata is stored in this play object. But a play object cannot mint moments on its own, because plays need to be added to sets. And a set represents like a series of connected plays. Plays can be added to sets, and then that combination of a play and a set is what we use to mint these moment collectibles, and each collectible will indicate which play and which set it came from and which combination it came from. Once plays have been added to sets, they will always be registered as being a part of that set, but they can be retired so that no more plays can be minted from a certain set. And additionally, sets can be locked to stop plays being added to it. So this is one of the ways that we can help encourage, and more than encourage, we can force scarcity on certain classes of moments. We can, if we want to only mint like 100 of a certain moment type. I'll just give an example. Like if we have a Steph Curry deep three-pointer, we only want to mint plays that are the three-pointer in the Steph Curry highlights set. We will mint 100 of these moments, then we'll retire that play from the set, and then after that, we know that there can be no more moments minted from that combination, because plays cannot be added to a set after they've re-added to a set after they've been retired. And then, but additionally, if we want to have a variable number of moments minted for a certain set and restrict that based on time, we could open up minting for a week and say whenever somebody wants to acquire one of these or buy one, we mint a new moment for this, and only mint until that time limit has been passed, and then the play is retired and the number of moments is limited by how many had been minted in that time period. So we have a lot of different mechanisms to be able to restrict, to ensure scarcity for the NFTs that we're minting for these. And then kind of going off on that, a play is not restricted to a single set. So going back to my Steph Curry three-pointer example, that Steph Curry three-pointer could be a part of a Steph Curry highlights set, but it could also be a part of a three-pointer highlights set or a 2018-2019 season set, and plays don't ever get completely retired. They can always be, someone could add the Steph Curry 3-pointer from 2018 to a set 30 years from now, if they wanted to do, like, then it would be like a retro set, even though it's contemporary now. But so there's a lot of flexibility with ensuring scarcity and minting these moments. But you're probably wondering how we create these plays and sets, because we wouldn't want anyone to be able to create these. And I mentioned earlier that we don't have, for managing access to these functions, we don't have a traditional access control list like Ethereum and Solidity does. In Cadence, no, let me explain this first. So this is how we represent, how a moment is represented in Topshot. So each moment has an ID, which is its global moment ID. This ID differentiates it from every other Topshot moment in existence. And then we have the set ID that maps to the set that this moment was minted from. And then we also have a play ID, which indicates which play that this moment was minted from. And last, we have the serial number. So this represents where in a play and set combination a moment was minted in. So if there were 100 of these Steph Curry 3-pointers minted in the Steph Curry highlights set, this would say this moment is number 12 of 100, or number 60 of 100, just to indicate where it is in that set and play combination. All right, so I want to get back to how we actually create these plays and sets. So, like I was saying, in Solidity, we would have this access control list that just says that we want to check every time someone calls a function. We want to check who they are, and if they have a certain address or certain account, certain identity, we'll allow them to access that functionality. But if they don't, then we revert. And this is, to give an analogy, this I like to think of this as kind of like having, like if you're in an important like government research facility, having a big public control panel that has all these buttons on it, that anyone in the world can walk up to and press a button that could do something innocuous, or it could do something extremely dangerous. But when somebody presses that button, the machine scans their retinas, verifies their identity, and then if they are the right person who's allowed to access that, then the button press activates whatever functionality it's associated with. And that is kind of how access control lists in Solidity work. Anyone can call these privileged functions, but will get rejected if they're not one of the authorized accounts. But in Cadence, we use what is called capability-based security. With capability-based security, it's not based on who you are, but it's based on what you own. And what you own are capabilities that are kind of like special access token objects for accessing certain functionality. So to go back to my analogy, instead of having this giant master switch or this giant master control panel that anyone can access, the members with privileged access instead would each get their own device, device that only includes the buttons that they will be allowed to press. So then they can use that how they wish because they've been given permission to do it. And then transferring that authority to somebody else is quite easy. You give them your device, and in Cadence's case, you give them this capability object that gives you the authority to perform these privileged actions. This allows a lot greater flexibility because we can create a huge variety of different capabilities with different levels of access. So going to the Topshot example, we could create an admin that only is allowed to create plays. We could have an admin that can only create sets. We can make an admin capability that can do everything, or only create one that can mint a certain play or a certain set. And it's not restricted to what we initially put in the smart contract. We can create a new one whenever we just figure out what a new combination is. And then lastly, it's easier to audit. I came from the Ethereum world, and I've done many Solidity smart contract audits, and working with the access control list can be confusing sometimes, because you're having to think about like how different accounts, like with different levels of access, how it could be exploited. And with the capability model, this exploit of exploiting these privileged functions is actually not even possible, because a potential attacker wouldn't even have access to those functions because they're stored in this private object in someone else's private account. So this person wouldn't even know, this attacker wouldn't even know where to find them, let alone how to exploit them. So it's much easier to be able to look at the code and say, all right, this is safe. Like we can audit these private capabilities for bugs and things like that. But we know we don't have to worry as much about vulnerabilities because these things are private. So this is how we manage the creation of all these plays and sets and moments in the Topshot smart contract. We put it in this admin object, and the admin object is also a resource, because even though it's not a like a currency or like a token that has explicit value, it's still a very important object, and we still want to ensure its safety. And when anyone who we've given it to is using it, so we don't want it to be accidentally lost or duplicated. So this is why we've made it a resource. But the admin resource effectively has these functions in it to allow them to create new plays, create new sets, and add plays to sets, to mint moments, retire plays from a set, and lock a set, so that no more plays can be added to it. And like I said, an admin we can create different types of admins to expose different types of functionality of this admin object. And this ability, this capability-based security, it extends to all different, extends to everything else in Cadence. If a user wants to only expose the play ID of one of their moments in their collection, they could just hand out a capability to their moments that only shows the ID of that capability. And there's just so many different possibilities for that. But the goal is to kind of give the users and give the developers as much freedom as possible to be able to have the flexibility to do what they want with their collectibles and with their games and their smart contracts, while still retaining that core of security and safety and ease of use. So I mentioned this briefly earlier, but with the Topshot NFTs, since the NFTs aren't so directly associated with a single smart contract, I mean, they do get their definitions from a smart contract, but since these NFTs are actually stored in the owner's accounts, it's much easier to design and implement different smart contracts and experiences that use these NFTs that are completely separate from the original Topshot contract itself. You could make some game, like a game that uses these moments for some fun strategy game, or any third-party marketplace could make their own marketplace that easily allows users to trade and buy and sell these NFTs, and all they would have to do is just be able to import the definition from this central Topshot account, and then allow users to do whatever they want with it. And we're already doing that with some of our NBA experiences. So we've built our own marketplace smart contract for Topshot that just allows users to buy and sell their moments. Then we have experiences in the app, in the Topshot app, to where users can have different challenges to earn different combinations of moments. We have showcases that let users show off some of their favorite moments to their friends in the app. And then we're actually building a mobile game also, where you can use these moments to play in a strategic game, and so these can really be used in so many different ways, possibilities. It's really just limited by your creativity. So if you're interested in building experiences like this, we've recently open sourced a bunch of our tools, and we also have we also have a online browser IDE to be able to practice with this. So if you go to play.onflow.org, we have the Flow Playground. This is a place where you can write smart contracts and deploy them to a emulated Flow blockchain, and then write transactions and run them to test your smart contracts and interact with them. So this basic one that we have here is just like a hello world smart contract that just has a function that returns a hello world greeting, and we just print that. And you can work with multiple transaction signers. You can run scripts to read data from your smart contracts. And once you've gotten familiar with Cadence, or if you just want to jump right into to actually developing apps, I'd recommend going to github.com/onflow. We've open sourced many of our repositories. As you can see here, this is the Cadence repository. We have a JavaScript developer toolkit for building JavaScript applications. We've got repositories for the kind of official standards for non-fungible tokens and fungible tokens on Flow. And then we've got Go SDK, the Flow Playground repository, and a few others. So if you're interested in getting more involved, we definitely recommend checking out some of these repositories. And also for NBA, we will be open sourcing the NBA smart contracts in the near future. So I would also keep a lookout for that. We'll inform the community when we do that. But yeah, I think that's all I have for this presentation. So we've got a little less than 20 minutes for questions. So does anybody have anything they want to ask?
Okay, thank you, Josh. I have a few questions that I saved from the chat while you were presenting.
Okay.
I'm going just to send you over to your private chat on Zoom, so you can just, if you could, read them loud and just give some answer, and then we can open up the mic for further questions if the audience wants.
Yeah, that sounds good. Okay. Let's see. Okay, I'll just start from the top. So we got a question from Daniel asking where the videos of these highlights would be hosted. So we would like to figure out a way to host them on IPFS or something similar in the future. But currently we just have our own private hosting for the videos that we control, kind of like what we've done with CryptoKitties. Then we have one from Eric Elliott. A single person may have many different wallets. Can a single person authorize multiple wallets to manage transfer collectibles? How is recovery handled if somebody loses wallet access and keys? So yeah, a single person, we wanted in designing and building Flow and Cadence, we want to give users as much flexibility as possible with managing their wallets and their account keys. So you can define, you can create multiple accounts for yourself in Flow and multiple wallets if you want to have a more sophisticated way of managing your collectibles. And each account has multi-sig functionality built into it. So if you want to have greater security and reliability on your account with your keys, you can, if you lose a key, you can use your other account keys to be able to recover that key or remove from your account and create a new key in case that one is lost and you're not sure of its safety anymore. Does that answer your question, Eric? Yeah, awesome. We also got a question from, let's see. Oh, Katie answered some of the questions. Emily answered some questions.
Badly. I answered a question badly.
Eric asked, I have a use case where we both have owners and holders. Owners assign holders and only the holder, not the owner, can actually use the resource. Is that representable? Yeah, that is, I believe that's representable because, oh, Max answered that one too. So yeah, but I'll answer for everyone. So if you have a resource in your account, you can allow, using this capability-based security that I talked about, you can allow other accounts in the network to have access to that object, and you get to choose kind of what levels of access you want to give others. If you want to have them, give them full access, that's possible, but you can make a capability that only gives them access to the parts of it that you're comfortable giving, so others can use it, even though it's still stored in your account. There's actually we have a place in account storage that is called it's the private section, like the private capability storage section, where you would store capabilities that have been given to you from other accounts that you want to be able to use, but that you don't necessarily want anyone else to use because they were kind of, privately given to you. Does that help, Eric?
That works even if if you're the owner, you don't automatically get like super user access to all of the capabilities.
If you're the owner of the resource, you have super user access to all of your resources, and you can create any kind of capabilities from the resources that you own.
Yeah, so that's what we specifically don't want.
Oh, really?
I suppose we could like take it a layer above that abstraction and just not have the owners actually own the thing. I don't know. We want the owner to be able to transfer tokens back and forth, but not actually be able to use the tokens. So maybe that's not an owner. Maybe that's like a controller or something like that.
Yeah. It's definitely possible. I mean, you could, if you don't want them to use a certain type of token, you could store that token in a different resource that only the resource that's stored in the person's account only exposes enough functionality to transfer it, but to not actually use it.
Yeah, maybe the owner could actually be a smart contract, and both the real owner, like the person who controls the transfer, and the user of the resource are not actually owners.
That could work. I'd love to talk with you about it more. So feel free to reach out to me on Discord if you want to discuss it more. No problem. Let's see, what else do we have? Let's see. How is the actual video reference stored in the contracts? Is it just a unique ID that requires additional metadata from the backend server, or is it linking directly to the actual clip to be used for third-party apps? So kind of like I mentioned earlier, the video reference currently will not be stored in the smart contracts. We are still figuring out ways to do that, but currently our videos are just tied to our database, and if you want to fetch the video for a certain moment, you can get the moment ID on chain, and then we just find the video in our database. So yeah, but we are looking into. I've been looking into, and I've been talking to some developers in the space about having fully on-chain storage. And there's an issue open in the Flow NFT repository for discussing on-chain metadata. So if anyone's interested in that too, we would love more input and feedback on that. So please get on that issue, and we can discuss this more. Then let's see, are all resources in Cadence publicly visible on the chain? So all resources are publicly visible on chain, just like all other public blockchains. It's not something that's easily readable. I mean, if you need to like have a more sophisticated way of like reading the data that's stored in an account, but it's definitely possible. But it's just, when I say the resources are private, I mean more it's private from a programmatic sense, like within Cadence. Like Cadence code controlled by external users would not be able to look at the resources or do anything or access the resources in your account unless you gave them permission to. Then let's see, got one from Mackenzie. In my view, it's enough to store URL to a video and NFT. The idea is not to preserve the video content itself. Okay, so that kind of relates to the last question. So Travis asked, any relation to the Cadence language to the mobile game? So currently, for the game, we don't have a smart contract that is used for the game yet. We're just testing it on its own before trying to make any sort of blockchain integration. But we do definitely want to make on-chain gaming experiences for Topshot as well. But those haven't been fully designed yet. Then let's see, Brock said, flow of the smart contract is published directly inside the user account. It's Topshot case. The admin resource was in the contract. How could that resource is binded to a single account? Like in Solidity by an address binding? Then Max, okay, yeah. Yeah, so like Max said, with that admin resource, we create the admin resource at deployment time and store it in the account that the contract was deployed to. This is something that I forgot to mention during the presentation, but for resources not being able to be forged, the way that we enforce that is that a resource cannot be created anywhere else besides the contract that it was defined in. So any functions or code in the contract can create resources and move them around, but nowhere else can actually do that. So yes, for this example, we create a new admin resource and we store it in the storage of the account with the contract in it. And the admin resource also has a function on it to create a new admin resource in case we want to have multiple admins. So let's see. Okay, one from Antonio. Are Flow and Cadence fully open source? So Cadence is fully open source now. The repo that I showed when I was looking at the OnFlow GitHub page, that has the complete implementation of Cadence in it. Flow has not been fully open source yet. We're still working out some kinks internally and doing some pretty intense testing for the full network, but we definitely will be open sourcing Flow in the near future, just not quite ready yet. Then Brooke said, in Flow, there are some kind of API to get the resources minted by a smart contract. We don't have a specific API to find out every resource that's been minted by a smart contract yet. But given that, assuming that a smart contract has defined an event which notifies external programs that like a NFT or a resource has been created. Like for example, in the Topshot smart contract, we have a moment minted event that is emitted every time a new moment is created. Those events are recorded permanently in the blockchain. So you could you could filter for all of the moment minted events and find out every single moment that has been minted from the Topshot smart contract. It's a little bit harder to find out where those resources actually live, like which accounts they live in, because users can move resources in and out of their accounts without emitting events. With Topshot, if a user withdraws and deposits kind of given in the way that we've defined it, like with the collections, then events are emitted every time that happens, and you can just fetch all of the deposit events to find out all like the owners of each moment. But it is possible to get around those event emissions and store it somewhere else. But if somebody didn't store their resource in this collection, then it would be much harder for them to interact with common Topshot functionality, because usually we expect users to have them in collections. So yeah. Another one from Eric. No, that's just an answer. Let's see. Mackenzie asks, will it be possible to transfer Topshot moments into other accounts outside of Topshot? So yeah, that kind of relates to what I was just saying. You can move it into other accounts outside of the Topshot based collections. And if you really wanted to do that, there's no problem with that. But like I said, if you moved it outside of the Topshot collection, then it would be harder to interact with some of the functionality that we're building into our smart contracts. But like I said, it's a blockchain, so users can do whatever they want with their moments, and there might be a third party Topshot app that doesn't require that. So it's really up to the user. So looks like that's all the questions that were in the chat. Does anybody else have any questions they just want to ask in person, or I guess not in person, but on the call?
Yes, if there's anyone else that has an unanswered question, we'd love for you to unmute and ask directly at this point.
Yeah.
Okay, it seems like everyone.
Hi. Sorry, I have a question. Hi.
Okay, Daniel,
Hi.
go ahead.
Hi. So I saw on Discord some people were asking when is the mainnet supposed to go live. So when is the mainnet going live?
Wait, do you want to?
Yes, I can talk. So we don't have, of course, a hard set date, but we can say that, for example, the public testnet is going to be released in the next few weeks. So anyone interested can start playing around and deploying contracts on top of it. We are planning to release around the same time, if not like just slightly later, by a week or so, the candidate mainnet. And then we will iterate from there, from candidate to beta mainnet and so on. So if you are interested in, trying out our testnet, public testnet, feel free to, join our Discord. We'll start onboarding, developers one-on-one basis before the public launch, and then we're happy to, walk you through with anything that you need to get started.
Yeah.
Hopefully that helps, Daniel. The short answer is very imminent, so it's not next year, but very short. I guess since now it's 4 o'clock and we're coming to a close to this webinar, Josh, could you just briefly remind people like how they can get involved in both, contributing to some ideas like the storage, meta transaction storage on chain, or like, if they want to learn more, and how can they stay updated?
Yeah, for sure. Yeah, we have a pretty active Discord. So I should have put a link in the presentation, but I don't know, Wei, if you want to find an invite link. We have a pretty active Discord, so please, if you have any questions about the protocol or Cadence or for writing smart contracts, please reach out on Discord. We can answer your questions. Then we also have a lot of documentation at docs.onflow.org. And if you want to read more about Cadence, I give a very high level overview of Cadence, but in the docs, we get much deeper into the design methodology and tutorials and examples. So please check that out. And then we're also we're accepting contributions on our open source repos. So if you want to dig into the Cadence language design, we'd love to get more people involved in that. For me specifically, I manage the Flow fungible token and non-fungible token standard repositories, and I'd love to get more people's inputs on those standards, because we're going to be using those for the actual official Flow network token. Is going to be a smart contract on Flow that implements this fungible token standard interface, and the Topshot smart contract will implement the official NFT standard interface. So definitely would be great to get some input from the community on those. And then also there's the SDK repositories, JavaScript and Go. If you want to learn more about actually building applications that use Flow, those are great to look at. And again, we're always accepting contributions and would love to get more people involved. So thanks everyone for joining.